Welcome to Nexaspaces, your ultimate guide to IoT automation and smart home solutions. Imagine walking into your home, saying a simple command like, "Turn on the lights," and watching your space come to life. Today, we're taking you behind the scenes to explore how voice assistants control IoT smart devices and how Nexaspaces can make your home smarter, safer, and more efficient. Contents. 1. Core components involved. 2. How it works, step-by-step process. 3. Key technologies and protocols. Ecosystem integration. 5. Advanced features. 6. Challenges and limitations. 7. Example scenario. 1. Core components involved. Voice assistant. The software, and often hardware, like a smart speaker that processes voice commands. Examples include Amazon Echo Alexa, Google Nest, Google Assistant, or Apple HomePod, Siri. IoT smart devices. Physical devices embedded with sensors, software, and connectivity. For example, Wi-Fi, Zigbee, Z-Wave, that allow them to communicate over the internet or a local network. Examples include Philips Hue lights, Nest thermostats, or smart plugs. Cloud services. The back-end infrastructure provided by the voice assistant's parent company. For example, Amazon Web Services for Alexa, Google Cloud for Google Assistant, that processes commands and facilitates communication. Network. A local Wi-Fi network or other protocols like Zigbee or Bluetooth that connect the voice assistant and IoT devices to each other and the internet. User input. The voice command issued by the user, such as, "Turn on the living room lights." 2. How it works, step-by-step process. Step 1. Voice detection and wake word. The voice assistant is always listening for a specific wake word. For example, Alexa, "Hey Google," Siri. This is processed locally on the device using low-power audio recognition to avoid sending unnecessary data to the cloud. Once the wake word is detected, the assistant activates and begins recording the subsequent command. Step 2. Speech-to-text conversion. The recorded voice command is sent to the cloud servers of the voice assistant provider. Using natural language processing (NLP), and automatic speech recognition (ASR), the audio is converted into text. For example, "Turn on the bedroom lights" becomes a structured text input. Step 3. Intent recognition. The cloud service analyzes the text to determine the user's intent. This involves natural language understanding (NLUU), breaking down the command into actionable parts. For example, "Turn on" equals sign action, "bedroom lights" equals sign target device. Context awareness. If the assistant has prior context, for example, the user previously mentioned bedroom, it can infer which devices to control. The system matches the intent to a specific skill, routine, or action supported by the voice assistant. Step 4. Device identification. The voice assistant identifies the target IoT devices based on device names. Users assign names to devices during setup, for example, bedroom lights, kitchen thermostat. Device grouping. Devices can be grouped, for example, living room might include multiple lights and a TV. Compatibility. The assistant checks if the device is linked to its ecosystem, for example, via an Alexa skill or Google Home integration. Step 5. Communication with IoT devices. Once the target device and action are identified, the voice assistant sends a command to the IoT device. This happens through one of several methods. Direct cloud-to-cloud communication. The voice assistant's cloud service communicates with the IoT device's cloud service. For example, Alexa tells the Philips Hue cloud to turn on a light. The IoT device then receives the instruction via its internet connection. Local network control. For faster response times or offline functionality, some systems use local protocols like Wi-Fi, Zigbee, or Z-Wave. For example, an Amazon Echo with a built-in Zigbee hub can directly control compatible devices on the same network, hub or bridge. Many IoT devices rely on a dedicated hub. For example, Samsung's SmartThings, Philips' Hue Bridge, that acts as an intermediary. The voice assistant sends the command to the hub, which then relays it to the device. Step 6. Device action. The IoT device receives the command and executes it. For example, a smart bulb turns on or changes color. A thermostat adjusts the temperature. A smart lock unlocks the door. The device may send a confirmation back to the voice assistant. For example, the lights are now on. Step 7. User feedback. The voice assistant provides a verbal response to confirm the action. For example, "Okay, turning on the bedroom lights," or an error message if something went wrong. For example, "The bedroom lights are offline." 3. Key technologies and protocols. Wi-Fi. Most voice assistants and IoT devices connect via Wi-Fi for internet access and communication. Zigbee and Z-Wave. Low-power, short-range wireless protocols used by many smart home devices for local control. Some voice assistants, for example, newer Amazon Echo models, have built-in Zigbee hubs. Bluetooth, used for short-range control, though less common due to limited range compared to Wi-Fi or Zigbee. APIs and SDKs. IoT device manufacturers provide application programming interfaces, APIs, or software development kits, SDKs, that allow voice assistants to integrate with their products. For example, Alexa Skills, Google Actions, encryption. Commands and data are encrypted, for example, using TLS, to ensure security during transmission. 4. Ecosystem integration. Amazon Alexa uses Skills to connect with third-party IoT devices. Users enable Skills via the Alexa app to link devices like Ring doorbells or TP-Link plugs. Google Assistant integrates via the Google Home app, where users add devices and assign them to rooms or routines. Apple Siri works with HomeKit-compatible devices managed through the Home app on Apple devices. Cross-compatibility. Standards like Matter, a new smart home protocol launched in 2022, aim to unify ecosystems, allowing devices to work across Alexa, Google, and Siri seamlessly. 5. Advanced features. Routines. Users can create multi-step commands. For example, "Good morning" might turn on lights, start the coffee maker, and read the news. Scenes. Predefined settings for multiple devices. For example, movie mode dims lights and turns on the TV. Conditional logic. Some systems support if-then rules. For example, if the temperature drops below √Celsius go degree EFU, turn on the heater. Voice recognition. Assistants can identify individual users by voice to provide personalized responses or restrict access, for example, only allowing certain voices to unlock doors. 6. Challenges and limitations. Connectivity dependence. Most systems require an internet connection for cloud-based processing, though local control is improving. Compatibility. Not all IoT devices work with every voice assistant, requiring specific integrations. Privacy. Voice data sent to the cloud raises concerns about recording and storage, though companies offer opt-out features. Latency. Cloud-based systems may have slight delays compared to local control. Ambiguity. Misheard commands or vague instructions, for example, "turn it on," can lead to errors if multiple devices are present. 7. Example scenario. Imagine you say, "Alexa, set the thermostat to 72 degrees. The Echo hears Alexa and records your command. The audio is sent to iOS, where it's converted to text and interpreted as a request to adjust a thermostat. Alexa identifies the thermostat device in your home, previously linked via the Alexa app. AWS sends a command to the thermostat's cloud service, for example, Nest or Ecobee, or directly to the device if it's on the same network. The thermostat adjusts to 9 EFU and confirms the change. Alexa responds. Thermostat set to 72 degrees. From voice to victory, Nexaspaces brings IoT automation to life. Subscribe now for more smart world insights. Let's make your home brilliant together.